Solving quadratics using the quadratic formula. In this video, you're going to learn, once again, how to find the solutions to quadratic equations using a fourth method. This fourth method is called the quadratic formula. So the quadratic formula is very lengthy, or it's going to seem very lengthy at first, but trust me when I say that you're going to get the hang of it and you're actually going to end up memorizing this formula. So this formula is x is equal to minus b plus or minus the square root of b squared minus 4 times a times c divided by, so we're going to divide all of this by 2 times a. So again, looking at it, you're thinking, oh my goodness, how am I going to use it? Well, simple. In the formula, you see a bunch of variables. You see the variable a, and it's in here in the formula. We see b as well, so the value of b is going to be in there. And of course, we see the value of c. So all of these values that you are going to see or going to have in a quadratic equation, they're going to be substituted somehow, somewhere, in a specific place in this formula. So your job is to identify a, b, and c and place them where they belong. So that's the quadratic formula. It's the easiest, best way to go. When factoring doesn't work, so remember when you were doing factoring, we had some situations where it was not factorable. So when it was not factorable, well, that's all we could do. In this formula, whether it's factorable, not factorable, anything is going to work and we will be able to find the solutions. So going more into detail with the quadratic formula. In the quadratic formula, there is something called the discriminant. And what it is the inside part of the radical, which remember, it's the radicand. But in this case, it's called the discriminant. So there's several things that the discriminant tells us, and that is, if the value that you end up with as your discriminant is greater than 0, that means you're going to have two solutions, two different types of solutions. If the discriminant ends up being exactly 0, there's going to be one single solution. And if the discriminant ends up being less than 0, then there's no real solution. Why? Well, because remember, a number less than 0 could be -1. So if the discriminant is a negative value, we've already dealt with this. It's going to be no real solutions. The radicand cannot be negative. No real solutions is what we get. So let's see how it works. One thing you have to keep in mind is that a quadratic, when using the quadratic formula, it must be equal to 0. It has to be equal to 0. That's the one condition. From there, just identify a, b, and c, which we will in a little bit. So we have a, which is the value in front of the x squared term. So here we have the invisible 1. So a is 1. B is the value in front of x, the coefficient of the x term, or the middle term, is 3. And c is our constant, the value that has no variable attached to it. So once you identify them, you can easily substitute them into the quadratic formula. So I'm going to write it here on the side just in case we forgot what it looks like. X equals to minus b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. So we start off with x equals negative blank plus or minus blank squared minus 4 blank times blank, all of this is still inside the radical, divided by 2 times blank. Our job is to fill in those blanks, which we should already know how to fill in because we identified the values. So we have -3 goes in this blank, plus or minus the square root of 3 again in this blank, minus 4 times a, which is 1, times c, times negative 10, times all divided by 2 times a, which is 1. So it looks messy because of all these parentheses that are in there. So I'm going to simplify it just a little. And now we have negative times 3 is negative 3, plus or minus. So I'm going to fast forward a little bit to the future by looking at our discriminant. Remember, this discriminant tells you how many solutions you're going to end up with. 2 solutions, 1 solution, or no real solution. So it all depends on what the value is. So let's find the value. And the value of the discriminant is 49. So 49 is greater than 0. Therefore, that means that I should end up with 2 solutions. So again, all of this is in the future, thinking ahead. So I'm going to have 2 solutions. So I'm going to put 49. And everything is divided by 2 times 1, which is 2. So we have the negative 3 plus or minus square root of 49. But we know that the square root of 49 is 7. So I'm going to simplify a little bit more. So here we have our 2 solutions. We have x is negative 3 plus 7 divided by 2. And we're going to have x is negative 3 minus 7 divided by 2. So going back to this one, negative 3 plus 7 divided by 2. And we get a 2. So that's one solution. And over here we have x is negative 5. And in case you're wondering why, well, negative 3 minus 7, this is negative 10, divided by 2 gives us a negative 5. And here we have negative 3 plus 7 gives us a 4, divided by 2, and we get a 2. So sure enough, we ended up with 2 solutions. Okay, let's try it again. Find the solutions to the quadratic equations. We're going to use the quadratic formula. A, the coefficient of the x squared term, is 1. B, the coefficient of the x term, is 8. And C, which is our constant, is 16. Now, we were able to identify them easily because our equation is equal to 0. So perfect. Nothing to worry about. Okay, now it's time to substitute into the quadratic formula. And it starts off with x is equal to minus b, which is 8, plus or minus the square root of b, which is 8 again, squared, minus 4 times a, which is 1, times c, which is 16, and everything divided by 2 times a, which is 1. So we substitute everything correctly. Next thing we're going to do is clean it up a little, rewrite it. So negative times 8 is negative 8, plus or minus. So again, I'm going to take a moment and look into the future and already thinking, what kind of solutions am I going to end up with? 2 solutions, 1 solution, no real solution. So what I'm going to do is I'm going to look at the discriminant, which is 8 squared minus 4 times 1 times 16. And I'm going to see what that gives me. So I get a value of 0. So my discriminant is exactly 0. That means that, well, first of all, let's not forget 2 times 1, 2. The square root of 0, well, it's just 0. So really, we don't even need to include the 0 in there. So I'm going to erase it. So we get one single solution. X is equal to negative 8 divided by 2. But let's not leave it as a fraction like that because we can actually reduce this answer. And so we get negative 8 divided by 2 is negative 4. And we have one solution. One single solution. Another word for solution, as you learned, is a 0. So we have one single 0. Okay. Let's try another one. X squared minus 12x is equal to negative 23. We want to use the quadratic formula, which means this has to be equal to 0, and as you can see, it's not. So we're going to go ahead and move this term back over here where it belongs, and by moving it, we're going to add it over to that side of the equal sign. So now we have x squared minus 12x plus 23. Now it's equal to 0. So next we identify our a, b, and c value. A is 1, b is negative 12, and c is 23. Now you're probably thinking, again, a is 1. Yes, again. Right now you're going to see something different. So once you identify them, you can start and substituting these values into the formula. So it's negative b, negative 12, plus or minus negative 12 squared minus 4 times a, which is 1, times c, which is 23. All of this divided by 2 times a. So once you substitute, the next step is, okay, well, let's just rewrite it a little simpler. Here we have negative times a negative 12. Well, that changes into a positive 12. No more negative. Plus or minus the square root of. So again, take a moment, look into the future, look into the discriminant. So here we have negative 12 squared minus 4 times 1 times 23. Depending what the discriminant gives us, we'll find out what kind of solution we're going to end up with. And so our discriminant is a 52. 52 is greater than 0, so that means that we're going to end up with 2 solutions at the end of our problem. So again, this is just a little looking into the future moment. So 52 is our discriminant. And don't forget that all of this is divided by 2 times 1, which is 2. Okay. Well, 52 is not a perfect square, so we're going to leave it as is, and we're going to split this up into 2 answers. X is 12 plus square root of 52 divided by 2, and x is 12 minus square root of 52 divided by 2. Our solutions would be the simplified, round to nearest tenth. So in this case, we would end up with x equals 9.6 if we round to nearest tenth. And when we have 12 minus square root of 52 divided by 2, we get 2.4 as our solution. So here we have our 2 solutions. So let's try another one. 4x squared is equal to 4x squared minus 12x is equal to 0. So as you can see, maybe just by looking at this, you notice there's something different. Well, what's different about it is 1, 2 terms only, versus the previous problems we've been working with, there's been 3 terms. So that means there is a missing term. So this is a quadratic equation, ax squared plus bx plus c. We have the x squared term. We have the x term. What we don't have is this constant term. So our a is 4. Our b is negative 12. And since we're missing our constant, we're going to put a 0. For the purpose of the formula, we need a value. So 0, because it's not there. We substitute this into the quadratic equation, and we have x is equal to minus negative 12 plus or minus the square root of negative 12 squared minus 4 times a, which is 4, times c, which is 0, and everything divided by 2 times a, which is 4. So if we write this a bit, we're going to get minus times negative 12. Well, that gives us a positive 12, but we don't need to put the positive sign there. plus or minus the square root of, so again, I'm going to take a moment and pay attention to this discriminant and think, what am I going to end up with? How does a 0 affect what's inside? Well, so here we have negative 12 squared minus 4 times 4 times 0. Anything times 0 is going to be 0. So 4 times 0 is 0. 0 times negative 4, 0. So we just end up with negative 12 squared, which gives us a 144. So 144 is our discriminant. Now this value is greater than 0, so that means that we should end up with 2 solutions. Okay, so here we have x is equal to 12 plus or minus the square root of 144, and the square root of 144 is just 12, so plus or minus 12, everything divided by 2. So we have two answers. X is equal to 12 plus 12 divided by 2, and x is equal to 12 minus 12 divided by 2. Well, in this first solution, we're going to end up with x is equal to 24 over 2, which gives us 12. So this is our first solution. And our second solution is going to be 12 minus 12, well, that's 0. 0 over 2, 0. And this will be our second solution. Okay, so not bad. It's pretty straightforward, the quadratic formula. There's not many conditions except for make it equal to 0, and if you have a missing term, replace it with a 0 for the purpose of using a value inside the quadratic formula. With that being said, we're going to work out this last problem, which, as you can see already, it's not equal to 0. So the first thing I'm going to do is move the 10 over to make this equal to 0. So I'm going to rewrite 2x squared plus 5x minus 10 is equal to 0. Now, you might notice that in this problem, our leading coefficient is negative. In the previous methods, I had told you, let's try to make this positive as much as we can. We don't want it to be negative. Well, since we're using the formula, the quadratic formula, well, guess what? Whether it's positive or negative, it does not matter. So, the value of A is negative 2. The value of B is 5. And the value of C is negative 10. So I'm going to substitute all of this into the quadratic formula, which says negative b, which in this case is 5, plus or minus the square root of b, which again 5, minus, I forgot the squared, and it's going to happen, sometimes we're going to forget little details, minus 4 times a, which is negative 2, times c, which is negative 10. All of this divided by 2 times a, negative 2. And of course, it looks really long because of all the substitution. So all we're going to do is simplify it a little. We start off with negative or minus times 5 gives us negative 5, plus or minus the square root of, and one last time, if we focus on the discriminant, what is inside, we will find out exactly how many solutions we end up with for this particular problem. And this will result in a negative 55. So our discriminant is less than 0. And when it's less than 0, then we have no real solution. Why? And divided by negative 4. Why? Because we cannot have a negative inside the radical. So we're done here. Nothing much we can do. No real solution. Again, when the discriminant is less than 0, when the radicand is less than 0, in other words, a negative number, then that's it. You're done. No real solutions. So I hope this video helps you to understand how to use the quadratic formula. Bye.